if I was doing volumes, what you might want to do, rather than try and follow me yourself, just watch.
Yeah.
In 2D, I'm going to right-click, enter an equation, y equals xx. Don't need this square bracket in. And I'm going to drag this down here a little bit and put a point here and here. And select them both and right-click. I'm going to find an area. Oh, I need to be in advance for this. Forgive me. I'm just going to go View, References, General, Advanced, because I want to do calculus, and there are no calculus options in the junior. If you want these buttons to be bigger in the advanced level, there's more of them, so they are a bit small. But right-click, Customize, Options, Large icons. Just makes life a little easier.
Good. You don't need to buy losses. Good.
All right. Right, right down the bottom is Find Area. And you have all the usual rules. Let's do 5 divisions. And what we have now is a completely dynamic situation. I can move this around and whatever. However, I'm going to deselect that and just select the area. And you'll notice down here it says what the area is. So that's a bit small. So I'm going to double click on that. Click, click. And it should come up here in a status box. Now, those students who understand the integration process will be able to tell you what the actual integral from 1 to 2 of x squared is, and the answer is a 2.3 recurring. Okay, so this is an underestimate of this, yes? Why? Well, look, you can see these holes here. It's obviously an underestimate. Right. Now, with the area selected, do you see this fellow here? This is the other really, really useful button in Autograph. It's called an Animate button. You have the ability to animate whatever it is that makes this area work, which is the number of strips. So I'm going to click on this, and here we are. We've got 5 divisions. This button would change it to 6 divisions. This button would change it to 4 divisions. Right. The principle which I hope I've established now is never press a button without thinking about its consequences. So if there are 6 divisions, is this number here going to go up or down?
Up.
Well, it's got a long way to go, isn't it? It's going to go up. Ready, steady, go. Ah, that's better. On we go. Right. Now, let's keep going. Now, what you could do is hand this over to one of your students and say, tell it away when he gets there. Now, you know it's never going to get there, so you can go off and have a cup of coffee. But when you get back, it might have reached, say, 500. And, 2.33. Well, it's a page, settings. Let's bump that up to, and now you can see if I select this, got a long way to go, isn't it? 2.330334. Now, think about as teachers, what would you like to do now?
Rotate about the y-axis.
Because here it is, this is about as far as you could get with your piece of chalk, and over the years, I always used to teach this, and thinking, well, I don't know if they ever really understand what's going on. But now I've got the ability to zoom in on this. Do you see this zoom button here? It'll zoom where I click. Ready, steady, click. And that's going to zoom up. So as you're doing this, you invite the students to anticipate what's going to happen. And of course, eventually it comes to be local straightness comes through. You can get a ruler and show how incredibly straight this is, even though it's part of x squared. And on we go. And of course, eventually, you can see precisely what's going on. That's really nice. What you could do also is, and this process just goes on and on.
Amazing.
Just click on, if I can jump. I'm going to select this area now. I'll double click on it. Now, if I double click on any object, it goes back to the dialog box that created it. So I'm going to change it to the trapezoid rule. And again, don't press OK until you've thought about it. Is the answer going to be more or less than the exact answer?
More.
Now, trapezoid rule is going to put a triangle here. You'd think it would just about do the job, wouldn't it? But think. We've got an think of the curvature here, and the trapezoid rule is definitely going to be an overestimate. Let's see if it is. Ready, steady, go. See how you can get the students curious before you press a button. And there it is, miles over. Look at that, 987. Can we be sure? Well, let's have a look. I'm just going to deselect, and I'm going to zoom in here. What I'm expecting is that the blue of the trapezoid rule will eventually reveal the red of the equation on its right. So let's just see if we zoom in here. Is the red going to appear on the right or the left? It should be on the right. Have a look. Here it comes. Look at that. Isn't that fantastic?